Hello there. In this video, we're going to be going through how to create new probability distributions from existing distributions through applying just arithmetic to random variables. And this is all in the context of using the QPython package for discrete event simulations of queuing networks. So first of all, as a kind of preamble question, suppose that we've got a random variable x and it follows a normal distribution, and we've got a random variable y that follows a gamma distribution. How would we know if I take x plus y, what distribution does that follow? And in special cases, you can work out the math and figure out what that is. But you can also do this through numerical simulation. Instead of trying to do a fairly difficult or often difficult mathematics problem, sometimes you can just simulate from both distributions of x and y, and then calculate the resulting sum as a sample. So Q allows you to do this. Let's import Q. And let's define a distribution class. Let's just call it distribution 1. And we'll define a distribution to be assigned to it. So maybe we'll start with an exponential random variable with a rate of 10. And we might grab another distribution, let's say a gamma distribution with a rate of 1 and 2. So what Q allows you to do is say, maybe there's some sense in which I can add the results of sampling from distribution 1 and distribution 2. There's a little bit of an abuse of notation here, because at one level of analysis, we're talking about probability distributions, but it's actually only the random variables that we're allowed to add. Nonetheless, this is a convenient form of operator overloading in the QPython package, where I can assign a new distribution to be whatever the sum of the resulting samples of distribution 1 and distribution 2 are. Okay, so let's take a look at some samples. I should probably print them in this context. So dist1, we'll take a sample, and let's do the same for distribution 2. We'll take a sample. And also for distribution 3, we can take a sample. And so there are 3 samples from distribution 1, distribution 2, and distribution 3. And it might make sense to take a quick look at plotting these 2 distributions and getting a sense of how that looks when we've done multiple samplings. So let's open up, or import, I should say, matplotlib. And we just need the pyplot submodule. And maybe I'm going to take multiple samples instead of one. So I might go dists1, or just distribution 1. Sample, and we're going to take some collection of samples. And let's say that n is a constant that we've defined up here, maybe a sample size of something like 10,000, just to take a whole bunch of samples. Samples 1, and likewise we could do samples 2. And samples 3. Okay, so we've hopefully collected some samples, and we can make a plot well, let's actually add each. So let's go PLT, and we'll just do histogram plots. So samples 1, we'll set for 100 bins. And we'll do the same for samples 2. And samples 3. And then at the bottom here, let's take a look at what we've produced by just showing the plot. And spelling does count in programming. Make sure you spell the names of packages correctly. And there's a distribution plot. Now you can see there's some overlap. So maybe what we'll do is, for one thing, we can set an alpha level just to add some transparency to these visualizations. And I think we should also do something like label just so we know which ones are which. Distribution 1. Distribution 2. And distribution 3. And we can go add a legend. Now let's take a look. Oops, little typo. So that's not much better, but hopefully you can see that there are essentially 3 different plots within the data. We've got the blue, we've got the orange, that the blue is kind of tucked in really tight at the beginning here of this is distribution 1. The orange is our distribution 2, which you can see goes out a bit further. It's got a longer tail to it. And then we've got distribution 3, which was the sum of the samples of either. And it's even further out. As we add these non-negative values together, it's very much expected that the distribution will overall shift to the right a bit. So that's the basics of adding distributions, but Q allows us to do more than just add them. So we won't go through plotting every time, but we can consider that there's a few other things we can do. We could do distribution minus distribution. Q will also allow us to multiply and, yes, also divide. For more advanced operations where you're really trying to do some very customized thing that maybe requires a more complicated process, that in a previous video we showed that you can write a custom distribution where you just need to put whatever you need in the sample method for that distribution. But in some cases where you're just doing some simple arithmetic, this is a convenient syntax, a shortcut for creating custom distributions that are simply the result of arithmetic operators applied to the random variables. So hopefully that gives you something that you can use to more quickly build your simulations. And with that, I will catch you in the next video. Have a great day.